The biggest challenge we have with on-orbit servicing and debris removal in the short term is that none of the satellites that we've launched have been designed for that. There are no common interfaces, there is no way to easily refuel a satellite, and so we're having to come up with technologies that can work with different satellites, all built in very different ways by different manufacturers.
We're now trying to dock and interface with bits of fast-moving space debris. That requires huge advancements in machine recognition and docking techniques. All these need to be proved and verified before we can have a commercial service. So the real danger is, if these assets themselves become debris, you're now compounding the problem they're trying to solve.
Does anybody actually want their old satellite? Or would they rather put that money into a new system which could be much better for them? So our challenge is to balance what can we do with our existing infrastructure and what can we do with the new infrastructure.
So debris removal, because there's no framework internationally that funds debris removal, nobody's taking responsibility for it. So we could look forwards and say that perhaps to get a license in the future, you've got to have a plan as to how you're going to bring yourself down in less than 5 years, which is something that is being discussed. At the moment it's 25 years. But to bring down the stuff that's already up there, which is actually causing a lot of the problems still. So, we talk about EnviSat sitting at 800 kilometers and it's nearly 10 tons hurtling around in orbit and won't be down for hundreds of years. How do you bring satellites like that down? And some of this needs an international activity, so it will need the international stakeholders, the people that want to use space in the future, to come together and find a way to fund bringing that stuff down. Because it's not cheap to bring this stuff down. It's a complicated satellite system. There's a lot of delta V, a lot of fuel that you need to bring the spacecraft down, and a lot of complicated technical problems to solve.
We'll demonstrate next year what we call semi-cooperative rendezvous and docking. So that's where a target satellite, say one of the big constellations, has a docking plate that we can attach to. So that I think we will prove that technology next year.
The biggest commercial challenges facing the industry is this switch from small numbers of very expensive satellites into high volumes of much lower cost satellites. So in the same way we've solved the industry in car manufacturing from the days of handcrafted one-off cars, Henry Ford revolutionized how we manufacture cars. The satellite industry needs to undergo that same revolution to give us mass manufacturing techniques.
Space will become a lot more sustainable. We'll see satellites being reused, potentially with the combination of things like field programmable gate arrays. Then we'll see the ability to reconfigure satellites over their lifetime. And so the satellite itself becomes just a bus for many different types of application, rather than just a single dedicated purpose.